Unit 17, Part 5. So we're discussing loves, our paradigmatic two-place predicate, our paradigmatic relational predicate. Just distinguish the legal from the non-legal syntactical formulations, right? LXY, that's how you do the propositional function. This is Andrew loves Betty, LAB, and so on. Look what else you can do with two-place predicate, loves, LDD. What does that mean? That means Dan loves himself, right? You've got LXY is X loves Y, right? So first position, lover, second, lovey. You can have reflexive, you can symbolize reflexive propositions like this. Dan loves himself, LDD, right? Read through Klenk's examples about is it Bill giving himself to God. That's what is that? G blank blank blank. X gives Y to Z. X gives Y to Z, right? So Bill gives himself, Bill gives Bill to God. B, B, G, right? And you had Bill gives himself a gift. Bill gives himself a gift. Okay. Bill gives a gift to Bill. B, G, B, right? Her examples are like this. Klenk's, right? So notice that you have to pay very close attention to the position, right? This is, here we have B, B, G. Bill gives himself to God because it's G. You've got to read very carefully the propositional function as defined. So Bill gives himself to God. Okay, Bill gives Bill to God. Bill gives himself a gift, right? Now it's G for gift instead of G for God. Bill gives, it's B, X, Y, Z. X gives Y to Z. Bill is giving it to Bill, but that's the third position, right? Bill gives a gift to Bob, so Bill gives a gift to Bill, B, G, B. Okay, when I work through the practice exam 4, you'll see your translations you'll have to fill in some three-place ones like this, and this is how we'll do it. I'll be laying down the spaces, right, blank, 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 and then one by one putting the right letters in here. And that's also when you've got quantifiers, right? You have many sentences like there are in the practice exam 4 where you've got like a three-place predicate and there are some individuals, right? So there are individual constants. Some individual constants are going to fill some of those places, and you've also got one or two, sometimes three, quantifiers, and so it'll be variables going in those positions. And you just got to attend one by one about who's doing what to what, right? So where does each individual constant go for those? Where does each variable go that's going to be quantified over? Pay attention to things like this, just to go back to a simpler example. If I was asked to translate a sentence like Dan is loved by August, right, and LXY has been defined as X loves Y, I have to be attention, and it's not going to go, right, I'm again incorrect if I go D, A, because that says what? That says Dan loves August. This is Dan is loved by August. So Dan will be represented with the individual constant D. Where does it go? Like which position? Let me attend because the order really matters, right? This is the lover, this is the lovey. First position is lover, second position lovey. So I'm going to put down here, right? Who's doing the loving? Who's the lover? Loved by August. So what does this say? L-A-D, reading it back literally, L-A-D, August loves Dan, which is equivalent to Dan is loved by August. Okay? So why are relational predicates so cool? Because of all the different combinations you can use to make different kinds of sentences. So singular sentences, she defines a singular sentence as when all the places are replaced by individual constants, right? First letter of the names. That's a proper singular sentence. There's a few complications on her definition of singular sentence. If you look at that note 1 on, I think, page 318, if it's got a quantifier and a name, it has a name, so it's also a singular sentence, but it's the quantifier which determines the form. Don't worry about those complications, but anyway, she defines a pure singular statement as when every position is filled with an individual constant. Okay, these will be, unproblematically, these will be universal statements. So look at how we get these. Here I have got one of the two places filled with an individual constant, and the other place of my two-place predicate filled with a variable bound by a quantifier. In each case, we've got, say, A for Andrew, and we've got the variable x, and the universal quantifier binds the x in both cases. But because the order is different, x loves A versus A loves x, these say very different things. How do we read these? Okay, this says, for all x, x loves Andrew, or more colloquially, everyone loves Andrew. Okay, what does this say? For all x, Andrew loves x. Andrew loves everybody. Okay, very different. Those are very different statements. Okay, obviously. So the order very much matters. Okay, but look how cool relational predicates are. You can also replace. You can also fill both places of a two-place predicate with variables and have two quantifiers, have both variables bound, and we get all these possible combinations. And a really crucial part of this chapter is in learning to get a handle on relational predicates and them being bound by different quantifiers, is this page 319 to 21, really, especially when she goes through translating especially 3, 4, 5, 6 of these ones. First two will turn out to be pretty easy, but these ones require thought. Make sure you don't get confused about these. So we're going to go through them. All right, so you can have x loves y, lxy. What does this say? This says there exists an x such that there exists a y such that x loves y. Right. So as Klenk says on page 318 and again on 321 and 323, it's always when you've got multiple quantifiers, it's always the leftmost quantifier which determines the form of the sentence. Okay, it's very important. First one is an existential statement. Leftmost quantifier is an existential, right? So this just says, but this doesn't really pose any problems of interpretation. So there is at least one x for which the following is true. There exists a y such that x loves y. So it's just somebody loves somebody. Okay? The second one, there exists an x, for all x and for all y, x loves y. Right? For every single x, the following is true. Every single one loves everyone. For every single x, the following is true. For all y, x loves y. Okay? That's how you read this. And I'll say something now which should be very important when we read the next four, which we'll spend some time on. You should read this, right? You should read this as, okay, the leftmost quantifier determines the form. So sort of pause in your interpretation after the leftmost quantifier and ask a certain question. So just on the second one, for every x, okay, and what is it? It's a universal statement. Leftmost quantifier determines its form. A universal statement tells you that the certain formula is true of everyone. And what is it that it's saying is true of everyone? Well, the rest of it. For all y, l, x, y. It's saying for every single x, the following is true. For all of the y's, x loves y. Right? So that's true of this, the first one, for this first x in the set of We're restricting our domain to people here. Okay. So in take this. So for every x, so take this first person. I'm telling you what? I'm telling you this person loves everybody. And now take this other person. I'm telling you that person loves everybody. Right? For all x, for every single x, it's true that for all y, x loves y. So take every single one of these, and I'm telling you that for each one, it's true that for all the people, that person loves all the people. Okay? Okay. I'll do 3 through 6 in a new video. Let me just do what I forgot to do, which was also clarify these for the one variable ones. What do these two mean? This just says what? Again, we're going to have a difference in meaning, but this just says there exists an x such that x loves A. So that just says someone loves Andrew. Easy enough. And this one, there exists an x such that Andrew loves X. Andrew loves someone.